Welcome to Uni. What? Today we will learn about domestic electric circuits. Let's begin. What are the advantages of alternate current, AC, over direct current, DC? In alternate current, electric power can be transmitted to longer distances without much loss of energy. Therefore, cost of transmission is low. In India, the frequency of AC is 50 Hz. It means after every 1/100 second it changes its direction. Let us now discuss domestic electric circuits. In our homes, the electric power supplied is of potential difference V equals 220 volts and frequency 50 Hz. It consists of 3 wires. 1. Wire with red insulation cover. It is the live wire, positive. Live wire is at high potential of 220 volts. 2. Wire with black insulation cover. This is the neutral wire, negative. Neutral wire is at zero potential, therefore, the potential difference between the two is 220 volts. 3. Wire with green insulation cover. This is the earth wire. It is connected to a copper plate deep in the earth near house. The metallic body of the appliances is connected with the earth wire as a safety measure. Earth wire provide a low resistance to the current, hence any leakage of current to the metallic body of the appliances keep its potential equal to that of earth. That means zero potential and the user is saved from severe electric shock. Points to be noted in a domestic circuit. A. Each appliance has a separate on or off switch. B. In order to provide equal potential difference to each appliance, they should be connected parallel to each other, so that they can be operated at any time. C. We have 2 electric circuits in our home. One consists of current of 15 ampere for high-power appliances. Another circuit consists of current 5 ampere for low-power appliances. What is short-circuiting? Due to fault in the appliances or damage in the insulation of 2 wires. The circuit will offer zero or negligible resistance to the flow of current. Due to low resistance, large amount of current will flow. According to Joule's law of heating effect, heat is produced in live wire and produces spark, damaging the device and wiring. What is overloading? Overloading can be caused by 1. Connecting too many appliances to a single socket, or 2. Accidental rise in supplied voltage. If the total current drawn by the appliances at a particular time exceeds the bearing capacity of that wire, it will get heated up. This is known as overloading. Fuse is a safety device can prevent the circuit from overloading and short-circuiting. So, what have we learned? A compass needle is a small magnet. Its one end, which points towards north, is called a north pole, and the other end, which points towards south, is called a south pole. A magnetic field exists in the region surrounding a magnet, in which the force of the magnet can be detected. Field lines are used to represent a magnetic field. A field line is the path along which a hypothetical free north pole would tend to move. The direction of the magnetic field at a point is given by the direction that a north pole placed at that point would take. Field lines are shown closer together where the magnetic field is greater. A metallic wire carrying an electric current has associated with it a magnetic field. The field lines about the wire consist of a series of concentric circles whose direction is given by the right-hand rule. The pattern of the magnetic field around a conductor due to an electric current flowing through it depends on the shape of the conductor. The magnetic field of a solenoid carrying a current is similar to that of a bar magnet. An electromagnet consists of a core of soft iron wrapped around with a coil of insulated copper wire. A current-carrying conductor, when placed in a magnetic field, experiences a force. If the direction of the field and that of the current are mutually perpendicular to each other, then the force acting on the conductor will be perpendicular to both and will be given by Fleming's left-hand rule. This is the basis of an electric motor. An electric motor is a device that converts electric energy into mechanical energy. The phenomenon of electromagnetic induction is the production of induced current in a coil placed in a region where the magnetic field changes with time. The magnetic field may change due to a relative motion between the coil and a magnet placed near to the coil. If the coil is placed near to a current-carrying conductor, the magnetic field may change either due to a change in the current through the conductor or due to the relative motion between the coil and conductor. The direction of the induced current is given by the Fleming's right-hand rule. A generator converts mechanical energy into electrical energy. It works on the basis of electromagnetic induction. In our houses, we receive AC electric power of 220 volts with a frequency of 50 Hz. One of the wires in this supply is with red insulation, called live wire. The other one is of black insulation, which is a neutral wire. The potential difference between the two is 220 volts. The third is the earth wire that has green insulation, and this is connected to a metallic body deep inside earth. It is used as a safety measure to ensure that any leakage of current to a metallic body does not give any severe shock to a user. Fuse is the most important safety device. It is used for protecting the circuits due to short-circuiting or overloading of the circuits. And with that, we complete this chapter. Hopefully you had a fruitful time learning. Bye, and don't forget to subscribe. It's faster than the time taken for you to be attracted to someone.